So good evening and welcome to the second technology session this year. The first one, if you recall, focused on materials, issues of material flows, recycling, life cycle design. Tonight we want to take a slightly broader perspective on issues in technology and have a conversation about the role of design technology as an enabler or, more specifically, an agent of change. Our four speakers, which I will introduce in the course of the evening, will clarify what exactly they understand as today's enabling technologies. Very broadly, maybe philosophically, I think of technology as a mode of interaction with the world. And that's, of course, very broad. The world in our case being also specifically the world of design, design practice, buildings, etc. In this interaction, computation seems to take on an increasingly important role, while at the same time becoming ever more embedded, ubiquitous, and ultimately taken for granted. The pace of change in design culture, in practice, and in research has quickened in recent years, and advances in computation, in materials, and in the related areas of digital and robotic fabrication, as well as in other areas, take no small part in that evolution. I've argued before that technology has been a catalyst for much of the change in architecture over the past years, and I'm happy to put that hypothesis to a test tonight. The format of tonight's event will be four relatively brief presentations by our four guests, followed by a panel discussion that you're most welcome to join in on. So without much further ado, I'm going to introduce our first speaker tonight, Thomas Bock, who is professor at the Technical University in Munich, Germany, where he leads the Institute of Building Realization in Robotics, I believe the first and only of its kind in Europe. His research activities are centered on issues of automation and use of robotic technologies in building construction, starting with the design all the way to the production and usage period, and including reconstruction and deconstruction. Trained as an architect both in Stuttgart and at IIT in Chicago, he earned a doctoral degree in Japanese, by the way, from Tokyo University. In Japan, he was and still is involved in automation projects in the building industry. Today at Munich, his institute offers its own degree program and runs research projects that cover a broad range of issues with an increasingly multidisciplinary team of faculty, staff, and students. The list of Thomas Bock's accomplishments and awards is too long to even begin, so I just want to mention his leadership role in what seems like to be all international organizations and journals in the field of building automation. So please welcome Thomas Bock.
Okay, thank you very much for inviting me here. And in fact, I like it because I was here 30 years ago after I finished my thesis in IIT in Chicago, and I got some Council Tall Buildings Urban Habitat Award. So anyhow, today I want to talk about this, actually about the building, like the building becomes like a machine maybe, because I think everything related to the tools, things we make depends on the tools. So I'm always trying to link it up to the production or to the tool, and then of course the challenges we have, our socio-demographic challenges. So I'm gonna show you something about these technologies. Most of the time also I compare with other industries. It's performance based because I think the construction building industry needs more performance actually in each sense, not just in the energy sense, but also in the process and production sense or in the transformation sense. So this is just an example of some factory in Dresden. And so you get actually, when you buy a car or an airplane or whatever, since we are here at the Piper Auditorium, airplanes also developed, you know, quite fast. You get more performance for the money as the product developed over the past 100 years when you compare to the cars and airplanes 100 years ago. So I think we can learn something from other industries, and therefore we have to focus on the process. The process thinking, I think, is very important because normally architects and designers mostly have a product thinking. And Sometimes we leave the process up to the civil engineers, the construction managers, or to the industry, which is not good in a way. And but I think now we have chances to take the whole kind of total approach back, like the former master builders, maybe because of this new technology available. And so, so the production is something very important. Just showing you here some examples, which modular components, and you can have a very high degree of prefabrication value added, and ship it to some area and just plug and play the system or the building system till the on-site construction. And this input, I think, is very important to do the design work. So I have some kind of reverse engineering approach, looking at the end and trying to then to design the product. So anyhow, tomorrow I'm going to show a little bit more about this production technologies. Now I think because of the actual problems we have, you not so much in the States, but in European societies, East and West Europe, and also some Asian societies, Korea and Japan, we are aging quite fast. And so I think the process term, the notion of process thinking might get into the building by itself. So maybe you know the movie of Transformer, so maybe the building becomes like a transformer in the future. Here you see the changing, the aging of the society. So United States is maybe not so in a difficult situation because you have enough immigration, but Japan is pretty bad, and Korea and Germany. Also China will have a bigger problem in the future because of the one-child policy. But one of the pioneers of this kind of service robots, if you might call so, or systems, was Joseph Engelberger. He was also the robotics pioneer actually here in the United States. He developed the Unimate first robot, industrial robot, and I actually happened to meet him about 8 years ago, and we were at the same conference, industrial robotics conference. And I listened to his talk and he listened to my talk, and he got very excited about construction robotics because he heard the first time about it, and he said this is something very interesting because he always thought robots shouldn't look like industrial robots. They can be anything because construction robots, they have a very different kinematic. You cannot do much with industrial kinematics, industrial robotic kinematics on the construction side. So Engelberger got very excited. Actually, he's the American robotics pioneer. And here you see his first service robot for hospitals. And what is good about his thinking was that he designed a total system. He adjusted the periphery so this robot could travel around the hospital and bring medicine and whatsoever to the patients. So on the upper left, you see his first industrial robot, Unimate, was applied first from General Mills, General Electric, and so on. It was just a simple pick-and-place device. Okay, so what also I think buildings will have more to do with services in the future, and especially the performance also here will change a lot from all kind of devices we have in the building, in the room, that basically in the beginning it's just a physical component. For example, you know maybe these Toto or Inax toilets from Japan. Initially they have been just ceramics, and now the ratio from the electronics part or the mechatronics part and the ceramics part, the cost ratio is 1:1. And if you talk to the research people in Toto, they say it will be 2:1 and 3:1 in the future, in the near future. You can have all the diagnostics for diabetes and whatsoever and already connected to the hospital or your doctor if you want to have it, like on the right side. Okay, and then what I think, if I speak of robotics, I just don't mean the conventional industrial robotics kinematics or scheme as you know it. I think it can be distributed like, again, maybe an example, because here's the Piper Auditorium. I got excited, I just heard about it because I have an American commercial pilot license. So I think maybe actually an airplane is also a little bit of a robot. You have the pilot is actually the operator, and then you can, depending on how you fly along, you have an autopilot, you can set the heading or the altitude or everything automatically, so the pilot does not need to do anything. And just in emergency, he can override the autopilot, for example. So it's a kind of robotic system too. You have this distributed systems. And if you take this, for example, and you transform this idea to the building, then you end up with all these robotic subsystems, the sensor system, the control system, the programming system, whether it's offline or online. And all this, you can put it actually into furniture, into walls, into ceilings, into wherever, the environment. And for example, here you see this devices we are using, and we're actually building into our test apartment we are now setting up in our robotics lab. In the center you see a small 1:5 scale where we have an incorporated, it's like a thick wall. The inspiration I got from Japan, because the Japanese have very thick walls where they put in the futons and the kotatsu. So they have the notion of the multifunctional space, not like we have in the West, the bedroom, the living room, the dining room, but it's multifunctional. You can use it for sleeping, for eating, for working. You take out the kotatsu, then you can eat and work there, or you put the kotatsu back and you put in the futon and you can sleep there. So actually here also this thick wall has everything inbuilt. It has a toilet inbuilt, it has a cooking place inbuilt, it has a shower inbuilt, it has a refrigerator inbuilt, and it all slides out whenever you need it. And I think in the future, maybe now, what we are learning about, or what we are teaching our students in Munich is like we're teaching the traditional building structure, all the services, the appliances, the envelopes, and so on. And I think in the future we have to teach more about other systems which become active subsystems, like mechatronic system, microelectronics, and microsystem technology, and or these ubiquitous technologies which can permeate into the building actually. So, but nobody is actually teaching it, or I'm not aware of courses, so we are trying to teach it now in our master's course. So, and what else is important, also got an inspiration from United States, from Taylor, and one of his partners was Christine Frederick, and she did the same what Taylor did for the one best motion, or the one best, what was it called again? Taylor, the one who inspired Henry Ford, Winslow Taylor. The One Best Motion or something. The One Best Way. No, The One Best Way was his famous book. And Christine Frederick was also partner of Taylor, and she applied his thinking to the kitchen. And she analyzed all the kitchen work, and she actually rationalized or revolutionized the American kitchen. And there was an Austrian woman, but she used to work in Germany, and she came to New York and copied Christine Frederick's idea, brought it back to Frankfurt, Germany, and developed the Frankfurter kitchen. And everything, make a long story short, you're focusing on all the activities of daily life, whether it's in the kitchen or now we extend it to the bathroom, to the living room, to the bedroom, or whatsoever. And then we can actually program the whole process, and we can program the environment to support elderly or slightly physically challenged people in order to live independent life. Because what old people like, I know it from my grandparents and my parents, they don't want to bother you, call you and disturb you, and please stop by and help me. They try to solve the problems themselves. So I think it's good if they can, as long as possible, live in their place, because they like their place where they lived for many decades. And we have a saying in German, you shouldn't transplant an old tree. So it's better, they live longer, they are more happier when they can stay in their place. So I think maybe the whole environment can become a kind of a supportive environment. So now I'm going to show you some of our projects. It's all projects, always I try to combine industry together with other research labs. And for example, here's one developing a chair. It sounds very simple. Why should we develop another chair? There are so many existing, but this chair has all the sensors in there for the blood oxygen saturation, for the electrocardiogram measurement, the blood pressure, the weight, and it can give an alarm or give some advice if something goes wrong. So while you're sitting on the chair, the data are measured. And why we choose the chairs, because old people like to watch TV, they have their favorite chair. Okay, we can put the sensors into the chair. The next prototype, the problem is they shouldn't sit too much because then they get lazy, and the less old people move, the worse the problem. So I had this idea, again, inspired from the Transformers. They're called in Japanese Gundam or Gatai, to transform the chair into a kind of exercise machine. So here you see you can do exercises. Then the chair will recommend you, okay, you should do some exercise now. Don't become too lazy. And okay, so here, and then of course, everything is connected to get the data, to send it to the doctor. Also, this is pretty important for countryside places, like, I don't know the situation here in the States, but in Germany, in remote villages, there is there are not many medical personnel there, and nobody wants to be a doctor or how do you call it, physician? Physician? Yeah, in the countryside, because it's not very attractive. I mean, if I live in Munich, and when I walk from my apartment to the university, I can pass by all my dentists and whatever, optometricians and so on, no problem. But when I go back to the countryside, where there are about 280 people living in a small village, I have to travel for half an hour or more to find a hospital or something like this. So this could also be a solution for telemedicine in the future. So connected to the internet. And then, of course, we do some real usability tests, not only with young people, but also with old people. And here you see the first prototype of the chair that will transform also into an exercise machine. First, we're trying to do the rowing. The rowing is supposed to be, we have also incorporated some people from the medical faculty and from the sports faculty about to study all the best ergonomic movements for the elderly. And they advise us how to do it. Another project is together with Italians, where the problem is, of course, if you have a new building, you build a new building, you can already consider all the things I'm telling you. But the problem is the existing building stock does not have this technology. So we are developing a kind of modular system which you can transplant into existing buildings. So it has to be very small. You can bring it into even an old farmhouse and embed it into existing buildings or apartments. And here's a setup of our kind of laboratory where we have some, we simulate, for example, living room or kitchen or bathroom and so on. I bought an age simulation suit. I put my students and assistants into this age simulation suit, and then we try everything, how we can solve the problem with wheelchairs or this other device on the right. I don't know the English word for this one, rollator in German, rollators. I don't know, one way the people walk around in the city, you know. And so you feel like you can set the stiffness of the joints, and you have some glasses, you see like a 90-year-old man or something like this. And it's really interesting when you try it yourself. I already did this in the 80s in Japan, because the Japanese research institutes of prefabricated house makers, they have this kind of research because they developed a product for the clients. So it's really amazing. Suddenly you realize, wow, the design of the furniture is not good, and stuff like this. So, and here we actually design a modular system which is next to the entrance and the inside of the building. You see here, for example, here, this kind of inclined device is going up and down, because if people want to put on their shoes, it's not easy for elderly people. They can sit down and slightly, it lowers your body, then you put on your shoes. And when you get back from shopping, you can put your shopping bags and they don't flip over and everything is lying on the ground. So this device is holding your shopping bag, and then it lowers you can take off your shoes, and then the northern Italians or also the Austrians, the mountain areas, they have this certain device where they take off the boots because of the snow. They wear boots a lot, and they have this device where they put in the boot to slip off Stiefelknecht. I don't know the English word, sorry. When you come to Germany, I can show you. We can go to Austria or to Italy. They also have good wine there. And so this flips over automatically, helping you taking off your shoes. Here you have a monitor for communication, because some people have the problem. They leave the apartment in the night gone, and it's minus 10 degrees Celsius outside. So it warns you, it tells you, it tries even to people to prevent to walk out if they have dementia problem. But if not, then it tells you at least get some code, and if not, then it calls somebody to catch this person before they freeze to death, for example, or they get lost. So this furniture, which is a kind of wardrobe at the entrance with a mirror and a communication device, put the boots, put the umbrella, put the shopping bags, can be added later into an existing apartment. And it's modular. You can, whatever you need, you can buy it. Okay, here you see again some devices. This is traveling out to help to bring in the shopping bags. And yeah, and this is the first prototype. Here you see for 1 or 2 seats, whatever. Here, this is the part flipping out, helping you taking off your boots. And all this technology, which you also find in some robotic device, is now separated into this device and helping to communicate and whatever. Yeah, and you see, whatever you need, depending on your problem of physical challenge, it's a modular structure. So physically, or also the program, what this furniture can do for you, can be extended or expanded. It can be adjusted to any kind of corner layout. We analyzed several hundred buildings, and we found a modular coordination where it can fit in, adjust to many existing buildings. Okay, another project which we are starting this year is about the mobility. Mobility is a big problem, especially the interface. For example, we have devices where the people, we can lift them out from the bed, and we can, and they can move on to the toilet. But then at the interface is always the problem. From this lifting device to the toilet or into the bathtub, or at the entrance shift over to the staircase lift, and things like this. Always the interchange is the problem. Or when you are down there at the entrance of your apartment, how you get into the car, for example. And all these interfaces are not solved. And in here we're trying to solve it. We have an electro car company. We have some company which is remodeling existing cars, so you can get in the wheelchair, with the wheelchair, or the driver's seat turns out and brings you back into the car. This is a company which does virtual reality or augmented reality. This is a medical device company. Here we have a company which does wheelchairs, even automated autonomous wheelchairs. And this is us. This is the electro engineering department. This is the medical and sports department. This is the brain research group of the other Munich University medical department. And this is a service provider for elderly. So always I think it's important to have the whole network so you can bring the research and development into the market. This is the idea about this project. For example, we design a new type of wheelchair. The problem also is with the design of the devices for elderly or physically challenged people. It looks ugly, and whenever you see it, you know, okay, somebody lives here who has a problem. So we are also focusing a lot, emphasis a lot on the good design. Well, you can argue about the design. I think it looks better than the existing ones. I hope we're going to build this one. At least it looks a little bit nicer than the existing one. And it's also, of course, modular. You know, you can use it some parts of it, you don't need to buy the whole set. You can use the chair for other purposes as well. I always think about applications like a modular building kit, so you can use it for other applications as well, not just in a wheelchair. Okay, here, for example, is some device where we proposed some unit which is accessible for wheelchair. Here's a turning platform, because the problem is when you're with a wheelchair in an apartment, you need more space actually. So developers don't like it because they lose space. And so here with this turning platform, you can save more space. And then here with the toilet, which is more designed like a motorcycle, and it's maybe an inspiration from the toilet if you find in Islamic countries or even in Japan. You slide over like on a motorcycle. So it's easier to transfer over from the wheelchair to this toilet. Or here you can take the shower. And here you have a typical for washing your face and hand. And here on the other side, outside, you have the kitchen. So it's everything is a very complex unit. It's also modular. You don't need to buy the whole stuff. You can decide what function you want to have. Just the kitchen part, or just the shower place, or the toilet, or whatever. So it's a modular system. Okay, here you see the kitchen part and how you can shift over. You drive it in here, and you just slide over, and then you can use your kitchen, and this brings you to the right position, whether you need to wash dishes here or you cook something here. Okay, here you see it again on top, this how this toilet works, like a motorcycle. And then here. Yeah, I like this idea. We can discuss later. So this is the company we are doing the new wheelchair together with. It's a company which is also providing lots of devices, appliances for hospitals. It's also important to have companies which have the competence, because if you develop something and you show it to some medical doctor and they know exactly what company can do good products, and this is a major hospital equipment supplier. Okay, and here we do the motion analysis. Again, time and motion. This is what Taylor did, you know, Taylor Winslow and Christine Frederick. And now we do it for our apartments and to design for the independent lifestyle of elderly people. Or here's some other development where we had actually some rails on the ceiling. And here lots of accidents happen, for example, when old people get up at night and they don't find a light switch, and then they stumble and fall over. And then maybe if they live by themselves, after a couple of days, you realize somebody is not moving in the apartment, you get in and people are already dead. So here, this device realizes, of course, not with a camera, people don't want to be watched like Big Brother, but with infrared, and then they can show you the way where you want to go, and they can also help you get up. It's all suspended from the ceiling. Another project is a little bit more with typical industrial robot kinematics, but in this case it was the robot which had been developed for the Space Lab mission, D2, in the 90s. It's a lightweight robot. It's made out of carbon fiber, but a little bit expensive, about maybe $120,000. And but it's lightweight, so it only weighs 15 kilograms, and it can handle about 10 kilograms. But because it's lightweight, you can put it anywhere on the furniture to help you in the kitchen. But actually, I think this kinematic is not so well suited for construction applications or building applications. But anyhow, we have this project with this company, so we do it. And here you see what we are actually setting up now in our laboratory. This is a kind of testing device, modular. Everything is modular, so you can customize whatever the client needs or what really is demanded. So we can customize the kitchen, the bathroom, the toilet, the living room, the bedroom, whatsoever. Also, the setup, I can show you later, is not a typical construction industry setup. I used sections from the mechanical engineering, so I can change the whole space in 3 dimensions. Okay. Yeah, here back you see the kind of sections we are using. So actually I can attach here theoretically a linear drive. So I can make the wall can perform something. And it's a raised floor. Actually, I can do something from below. We have one project where suddenly the things you need appear around you when you need it, or from the ceiling. So it's a very three-dimensionally changeable space. Okay, and then the kitchen. Here we got some inspiration from McDonald's because they're very, very good how they organize their work. Not about the food, but the systematic approach how they do it. It's a little bit from aircraft. I refer a lot to airplanes because I like airplanes, I'm sorry. So, you know, when they bring you the food, when you take an airplane, and everything is very compact, how they heat it up, how they serve it to you. And this kind of notion, McDonald's notion, plus the business model of McDonald's, where we supply the person, because the problem is sometimes the elderly people don't eat properly, they don't drink properly, they have the wrong minerals and vitamins. So everything will be supplied for them, just like what they need to have the good nutrition value. Okay, and then here, this kitchen is changing as well, because it's always difficult if you sit in a wheelchair to move around in a wheelchair. So here I thought, okay, let's do the kitchen in such a way, like for a pilot. So the pilot has everything around himself. He can handle everything, you know. Used to be the flight engineer, but now it's only 2 pilots, and maybe we only need 1 pilot in the future. And so everything is configuring around the pilot. So I said, okay, we have to do the same with the kitchen, actually. So the kitchen can configure itself around the person in the wheelchair, for example. So the furniture becomes, or later the whole building becomes like a transformer, in my opinion. This would also be good because the investment in construction building is very high. In Germany, it's every second euro goes into some of the built environment. Of course, this is also including infrastructure, but this means huge investment, and I think in the future we have to deal differently. We cannot scrap and build. We have to find different solutions. This is the one I said where we took some ideas from the aircraft. You know, it's not rectangular like in the airplanes, because I thought it's kind of interesting to have this round kitchen as an island solution, and the other one I showed you before, you got into this round solution. So we're trying all different kind of solutions. Okay, so I think I'm almost through. This is the one inspired by Christine Frederick, and this is what we are trying to do today. And yeah, the idea is to have these customized services and the environment, whatever the people need, whether it's to allow their independent lifestyle. Okay, thank you very much.
Thank you, Thomas, for this preview of aging. I already feel a little bit better about the prospects. But I think there'll be lots of questions. It brings up so many associations, building as a machine, human-centered design, just many, many issues. We'll leave questions to the end. And I do want to also mention that you mentioned it briefly, that tomorrow from noon to 1 there'll be another presentation by Thomas Bach about the work in construction automation, the prefabrication of components, and the construction automation systems for high-rise buildings. That'll be in room 124. So let me introduce our next speaker. She's Rivka Oxman, who is associate professor at the Technion at Haifa, Israel, where she received a bachelor, a master, and a doctoral degree. Her work explores models of design thinking and design computation from a conceptual and theoretical perspective. She promotes design and design practice as a form of research. Her work has been published extensively in both scientific and other journals, and she's given keynotes at venues such as SIGRADI, CAD Futures, Cadrea, etc. Rivka Oxman is a fellow of the Design Research Society, and recently co-authored the architectural design issue entitled "The New Structuralism: Design Engineering in Architectural Technologies." This year, she is a visiting scholar at the GSD, working on new projects. Please welcome Rivka Oxman.
Where is my computer? It's right here. Okay, thank you. Thank you, Martin, for introducing me. The title of the symposium is Design Technology Agents of Change. As an architect and designer, to me, the change is really the most important change, is the change in our profession. The fact that we are willing to change our knowledge base, the fact that we are willing to be engaged in new skill, change ideas that we had before, is perhaps the most exciting things. We are willing to collaborate with engineers and constructions people, things that was not so obvious before, and I think we are developing new profiles for the profession. This is the most exciting things. Well, today, the convergence of design, engineering, and architecture are breeding a new material practice in experimental architecture. This shift is presented in this talk as highly dynamic synthesis of emerging principles of spatial, structural, and material ordering integrated through application of materialization and fabrication technologies. A formal concept is first conceived by the architect and subsequently structured and materialized in collaboration with the engineer. That's the way we were used to do. However, this process is no longer a posteriori. Due to design technologies, the architect is now involved with materialization process at the conceptual and at the generative level. The shift is defined as a highly dynamic synthesis of emerging principles of spatial, structural, and material ordering integrated through the application of materialization and fabrication technology. These approaches have developed new models that challenges orthodox working methods of architectural design. As a result, we are currently witnessing a transition in both theory and practice towards a level of involvement with material as a dominant model in design. Tectonic has been a seminal concept in architectural discourse that defined the nature of the relationship between the architect and the engineer, between form, structure, and material in design. Today, the contemporary ability to model computational processes simulating form, structure, and material behavior is leading to a new definition of tectonic content. It is the affinity between tectonics and digital technologies that enhances the integration of form, structure, and material principles. Digitally informed tectonics is a proposed term to describe and present these changes in emerging material practices. Tectonics. Tectonics is a seminal concept that defines the nature of the relationship between architectural design and its structural and material properties. The changing definition of the symbolic relationship between architecture and structure may be considered one of the formative influences in the evolution of this concept in different historic periods. In different periods, the emphasis has changed depending on contextual knowledge of place and culture. Contextual knowledge reflects local environmental conditions and cultural values, as well as traditional ways of building and construction. In different periods throughout history, tectonic discourse has continually redefined the elements of the tectonic relationship as well as their prioritization. Let's start with the vernacular. Tectonic in vernacular architecture. In tectonic in vernacular architecture, integration of form, material, structure, and construction proceeds as materialization process essentially without design, being the fruit of the builder experience and craft traditions. Gottfried Semper adapted the term tectonics to transform the concept form, that of the builder, to that of an integrated building system. He was referring to an explicit reordering of the physical relationship of structure and material. His reference to the nature is regarded an important reference to a classical model of tectonics in analogy to biology. The traditional Japanese house presents a correct expression of material, structure, and construction as a tectonic system that expresses the constructional potential of the material. In historical periods, advanced construction tradition encompass the structural system, building standards, and the construction processes which are closely integrated. The material systems are gradually transformed into formal systems that directly express both the material origin and the construction process. Frank Gehry Bilbao considered to be an early digital tectonics. In the early digital age, in buildings such as Guggenheim, Bilbao, the fundamental methodological difference is that the shapes were produced as individual forms and lacked, at the beginning, an inner integrated link with either structure or material. The link became stronger later. Gaudi's work is considered as a canonic example which introduce experimental analogical methods of form finding in design. You can consider that as an early informed tectonics. Sagrada Familia Church is considered to be one of the examples of digital tectonics. A significant contribution to the contemporary digital tectonics is work on the Sagrada Familia Church, where Mark Bury and his colleagues have developed a parametric design methods to model the missing components of the church. Gaudi, again, this is among the first methods of form finding that can be interpreted as fully informed tectonic process of design. The use of catenary modeling introduces experimental analogical model and was the basis for the development of latest form finding techniques. So, in order to link current technology and understand the contribution to tectonics, we propose the term digitally informed tectonics. The term reflects the information flow between design and construction processes. Having proposed the term, in form tectonics, we selected 7 representative case studies demonstrating the basic concepts and the principles of digital design and material fabrication in relation to informed tectonics. The first one is the rationalization model, which reflects interdependency between shape, structure, and material fabrication. In order to support integrated process and seamless workflow, geometrical modeling must incorporate consideration of structural constraints, material properties, and manufacturing technologies. The Skipper library, conceptual design was done by Fortex at 2009. Well, in this project, Helmut Portmann from Vienna developed a construction-aware digital design environment that incorporates knowledge of the material used, panel types, and panel geometry options. This way, it kept the information flow along the project development. Helmut Portmann is developing currently rationalization techniques to support informed processes, providing construction-aware design tools and enabling a completely digital workflow from design conception to manufacturing. I believe he worked with Zahadid, worked on the funicular station in Austria, where Bollinger and Grohmann and design to production were doing the construction and the fabrication. The second principle is getting the flow by using a computational, in this case, generative evolution design models. Lava voxel extension project by Klaus Bollinger, Manfred Grohmann, and Oliver Tessmann illustrates both the structural and the formal principles in the conceptual model of square-edge sponge configuration. The project is based on 3-dimensional spatial continuum that provides a close interlocking of the same elements for spatial and structural organization. The interdependency between shape and structure is maintained by using an element which share the formal expression and the structural attributes. The system properties are not defined by individual elements. They emerge from intricately informed generative evolutionary model without any top-down control. The interdependency between sets of elements is hardly predicted in this case. The structural performance of the configurations becomes the fitness criteria in this evolutionary process. The third example, the third model, is related to information flow achieved from design to code and manufacturing. And here you're probably quite aware of the work done in your own institute by Professor Martin Berthold, in which robotic bending work of individual metal components by Martin Berthold, GSD Harvard University, and his students illustrates the role of directed information flow from design model to code generator to robotic manipulation. Both design and robotic fabrication systems are informed in bottom-up fashion by local processes and control. The next one, again, talk about information flow. That's the work of Schurer, which his firm is turned from design to production. A model is redefined in each work project due to specific relationship among form, structure, and material in fabrication. So, requirements of the final fabrication and the construction assembly at the stage of design. Fabian Schurer, Design to Production, was involved with the project of Shiguro Ban, the Nine-Bridge Golf Resort in South Korea. And this is an example of continuing relevance of redefinition due to specific consideration of specific fabrication. Each project is crafted individually. There is no kind of generic system or generic way to deal with projects. So each project is crafted according to its specific conditions. In this project, woven timbers girders represent craft-like tectonics. The canopy was composed of woven timber girder elements assembled from detailed 3,500 glue-lam intricate detailed prefabrication segments. Intersecting girders were fabricated by CNC machine, as you see here, so it's ready for production. The five concept is the selecting of structural order. Construction demonstrates an interdisciplinary approach in which material first inform the structure and the form. So in this project, instead of working form, structure, material, the work was started with material, which then produced an emergence principle of structure, which create the form. So in the work of Yves Wijnands from ETH Lausanne Zurich, which termed the textile model, the application of textile principles applied to the context of timber. By twisting material component, in this case a timber sheet, into a stiffened structural component form, and structural principle emerged. So here we got a structural principle which is not usually demonstrated by timber. The component is then assembled into a fabric-like woven structure. The sixth concept, the sixth model, talks about digital materiality. I guess all of you know these people, Gramazio and from ETH and Kohler. In the following case studies, bricks that have geometrical attributes and constructional logic are encoded digitally as a particular material system. Formulating and scripting the logic of a design system as the interaction between human and robotic machine, including the geometric form, the structural elements of material components and their assembly logic, in a single mode of design, becomes the basis for the definition of digital materiality. Digital design code of complex material instructions can now drive design production in robotic bricklaying. I just heard they are moving now for another material, a timber material, and we'll see what's going on. Digital materiality, as defined by them, is informed tectonics by robotical technology, encoding the geometric of material components and their assembling logic. inform tectonics through coded variations in experimentation with digital tectonic system produce infinite size of experimentations. The last principle, the last but not the least, is the concept about digital material and variable properties. Digital material, the variable property model. In this model, variable properties of digital material are informed by performance attribute of a specific context, human or environmental. Digital material is computed and fabricated according to desired properties. And some examples. The best prototype for a chaise lounge, which exhibited in Boston Museum of Science, demonstrate how variable properties of digital material can be informed by specific context. In this case, the distribution of structural fitness, distribution of the body to produce desired properties. Another example is the copper skin currently in the Museum of Science in Boston, where variable properties of digital material are informed by properties of local thickness corresponding to strategic areas across the surface of the wrist in cushioning and protecting from hard surfaces. Again, variable properties of digital material are informed by structural loading and the distribution of structural stiffness in the work of Neri Oxman, presented here. In this case, properties of the shape and stiffness distribution are informed by a plane map. To summarize and conclude, today, the convergence of design, engineering, and architectural technology are breeding new material practice in experimental architecture. The term informed tectonics was proposed here to represent design technology as agent of change. Looking at this shift as a synthesis of conceptual principles of spatial, structure, and material ordering integrated within the logic of materialization and rationale of fabrication and manufacturing technologies as holistic model of design. I think this field is very exciting. It changes the way we think and perceive design, and I believe it will grow from the small scale of product design and building, and will lead to a different and refreshed way to deal with problem in urban design and other big-scale design. And I think it's not style that we are designing. Here, in these cases, all the cases that we demonstrated, the style was results of severe problems of environmental context and human needs. So I think it's the first time in history the style is not stand by its own as a style, but it's really as a result of a very conscious way of dealing with very, very difficult problems of global conditions. Thank you.
Thank you, Rivka. We should probably come back to the question of style in the end. It'd be interesting to talk about. I think it's good as many of us are engaged in very specific things to be able to take their time and step back and also reflect on what it all means and how one could think about the various different approaches. So with our third speaker, Paul Seletsky, I think we'll bridge over more a little bit again to practice from a different angle. Paul is trained in architecture at the Cooper Union, and he's the founding principal of ArcSphere, a digital design research and development practice. He's the former digital design director of Kieran Timberlake and Skidmore, Owings & Merrill, where he spearheaded research, development, and cultural change through the use of building information models. A licensed architect, Paul regards the strategic implementation of digital design as an ongoing process where R&D is applied through actual projects. So this is the kind of practice as the research lab. He's the active co-chair of the AIA New York Chapter Technology Committee, presiding for the past 9 years over a monthly lecture series highlighting technology and its impact on practice. And as someone who's been on that mailing list for those 9 years, I will say that it's been an impressive and really compelling cross-section of interesting and innovative work in technology. Paul Seletsky has lectured at numerous academic and professional venues, and we're happy to have him back at the GSD today. So please welcome Paul Seletsky.
Well, thank you, Martin, for the very lovely welcome and the invitation. I'm honored to be here. I hope you will not see my presentation as antithetical to the first two speakers, but it's not as visually stimulating, but it's more of a social discussion. I've titled this the AR Lab, and I wrote an essay not too long ago, having talked to an architect colleague of mine in New York, who said, Paul, I recently visited Yale, and I was very, very impressed with the facilities they have there, and the students have access to all of these new technologies and new robotic equipment and CNC machines. And there's a real problem that I see in that these students almost are being trained as though they were, as an analogy to medical students being given the latest technologies, but when they get back to, when they go into actual practice, it's as if they went from this very high technology and they're given a hand drill from Home Depot. So there's this real chasm between what's being taught in academia and what professionals are being given in actual practice. And this is a real concern of mine. And so I wrote this essay called the AR Lab, the Applied Research Lab. And the premise of this essay is basically to say, how can we bridge this chasm between academia and those in practice today? How can we get, for example, I work with the AIA in New York, but I also am now working with the AIA in Philadelphia. And to be very honest with you, I'm not so enamored with the AIA as a change agent for technology. I shouldn't say that too loud because it's being recorded. But how do we bridge this? How do we get practitioners to use this technology who don't have access to what you have in academia? And how do we bridge your transition from this wonderful world of academia into a practice where you're not disappointed, where you're not let down, where you feel that you can show those in practice what you've learned and what you're doing. So there's a very practical side to this. And I show this example of a design studio from 1910. And this is a studio at Kieran Timberlake that I just left about 3 weeks ago. This is not to denigrate Kieran Timberlake by any means, but it's to say that as much as we would like to think that we've changed in 100 years, we really haven't changed that much. We talk about a lot of the technology, but we really don't have the means to incorporate a lot of this technology into our actual practice. And so one would question, why is this the case? Why don't we have the financial resources? Where have we become marginalized? And we're very, very good at talking about sustainability now and how we're dealing with sustainability. The fact is, if I told all of you, let's leave our cars on for 24 hours a day, let's just let them run for weeks and weeks on end, you'd say, you must be mad. You know, why would we leave our cars running 24 hours a day for weeks on end? Well, when we leave this room, when we leave this building, it will be heated and it will be cooled 24 hours a day. It's a machine that does not get turned off. And yet we're not really thinking of our buildings in this way. We're certainly talking about LEED certification and LEED forms, and we're filling out these forms to suggest that we're now environmentally conscious. But really, what are we doing? Are we rethinking, as Kiel Mo and others are now starting to discuss, how do we go from technology that was invented over a century ago in terms of heating and cooling air and circulating air to materials that might be smarter and might emit heat or might emit what they've stored in terms of energy when we don't necessarily need to run these mechanical systems 24 hours a day. So I like to think of architecture and architects as analogous in their importance to the profession of medical research and medicine itself. And I look at the surgeon or the medical practitioner and I think, well, what distinguishes the medical practitioner? And it's not purely looking at a film and saying, this is the problem. It's a series of taking conditions, examining conditions and studying conditions, and then coming up not with one answer, but with a series of options, with a series of interpretations. So we look at conditions as architects very similarly. We like to know what is the given problem, what are the given conditions, and how do we synthesize this into not just one option, but many options. And so we have the technology that enables us in many ways to monitor what's going on. But the problem is that we're monitoring this in a post-rational manner. We're coming up with designs, we're coming up with morphology, and we're using the technology post-rationally, post-morphologically, to sustain or to validate what we've designed. It's not embedded within the design process itself. And we have our heroes, certainly, and I'm going to sort of digress for a minute into where some of these heroes have taken us with the technology. And if you notice in the center, there's Howard Rourke. And I don't think we've actually separated ourselves from the historic notion of the heroic architect. And we live in a very collaborative environment. So we have to redefine the nature of the auteur. Now, I'm not suggesting that we shouldn't have our heroes and we shouldn't have our authors or our auteurs, but this is a series of slides that I call separated at birth. And a lot of what you see is in some ways mimicking the digital technologies. In some ways it's trying to epitomize the digital age. But there's an issue here, and I'll get to that as I go through these slides. So I'm not going to name names. This is by no means to denigrate these architects or their ambitions or their ideas. But it's to say that we need to go beyond what we're using the digital technology in terms of formal production. And so you can see here there are a variety of themes that have been generated digitally and have been produced digitally, and some of them are evolved from the paper clip, and some go into an expression structurally of what exists. And I certainly love what Rivka has presented as an informed, as an intelligent approach toward structural representation and towards structural expression. But we start to see examples of some, I can't say mimicking, but where a theme is developed and it's taken and it becomes a kind of fad in some ways. And we even see it in the examples of the software technology companies and how they're recognizing this. But again, all of this goes toward a question of when do we begin to embed the technology into the design process itself. And I think it's notable that Rivka, for example, has presented Gaudi and Mark Burry's examination of Gaudi, because beyond well before the computer was brought into existence. It's clear that Gaudí had the parametric mind to understand structural integrity and structural expression, and didn't necessarily need the computer to see this. So where does the computer help us to augment some of these ideas? And especially in practice, where do we start to examine in practice how the computer is not an answering machine, but is a means toward creating more options in less time and starting to communicate with clients in a different way than we're used to? And a lot of the difficulties, for example, with building information modeling are starting to overturn the nature of our labor and what we produce in terms of our labor, both in the early stages of conceptual design as well as in the production of our documentation. And I'm going to get into that in a second or two. So the idea of historic reference is nothing new, and we can see this in examples from Mies to Frank Lloyd Wright. But this example between Le Corbusier and Richard Meyer is striking, because Corbusier was taking the idea of industrialization and trying to turn it into an aesthetic that spoke to the period of time that we lived in, to say that we're no longer in this period of ornament, that our architecture should represent us technologically in what we can achieve. And again, with no disrespect to Richard Meyer, but the idea of the modernist is now an aesthetic representation. As much as we like to look at it, it no longer adheres to the polemic that is brought forth by Corbusier, but really talks more as in some ways an aesthetic billboard or an aesthetic advertisement toward what we can achieve. And so I show this slide of the 1950s and 60s cars, because you can say, look, we were at our height in terms of industrialization. We could produce anything. And we could design the most beautiful cars, and it's striking how we could take materials and shape them into whatever we wanted. And so aesthetically, you say, well, these are classic cars now. But what performative function did these fins and these shapes really serve? They didn't serve much in terms of a performative nature. They served to satisfy our aesthetic ideas or our aesthetic needs, which is certainly important. But in terms of actual performance, they really were kind of the icing on the cake. They're really just an embellishment. And so I say to you, with all of the digital technology we have, there's really no shortage in terms of what we can produce with geometry, but what we do lack is a credibility amongst our clients, amongst ourselves, in terms of what we're doing. And I show this slide. It's an example of bloodletting, which was a treatment to cure a variety of illnesses from antiquity to pretty much 125 years ago. And so if you had the flu or if you had a cold, a doctor or a so-called doctor would basically make incisions and try to replenish your blood supply in the hopes or the belief that this would cure you of your illness. It was a medical practice based on intuition and not on scientific research or any scientific method. And I show this example from Honoré Daumier, who was a French caricaturist. He creates this fictitious architect, and the architect is having a conversation with his client, and the client is very upset over the cost of the project that his architect has designed. And the architect is saying, well, you took my plans, you changed them, you didn't consult me, and so it's your fault it's costing this much more than I had established. But we can look at this is from over a century ago, 2 centuries ago, and say, well, what has really changed? We're not really allowed to talk about costs. We're not really allowed to talk about means and methods. We're very afraid of our risks and our liabilities. So in terms of all the technology and our empowerment as a profession, we've really gained very little. And these two slides are examples of building information models. They're basically saying, look, we can create this geometry, we can slice this model thousands of times and not have to draw all the lines and in the floor plans or the sections, but we can automate the production of our work. And we can certainly peel away the model and see all of these geometric objects, but we don't really know the behavioral properties of these objects. We don't know what sustainability characteristics they have. We haven't really quantified anything. And so we are faced with certain situations where we're questioned in terms of our stated claims to energy performance. We have advances in other areas of neurological science and neurological research, how we perceive things, what makes us comfortable supposedly in certain spaces, what makes us uncomfortable in certain spaces, but we don't really have a means to incorporate this into our design methodologies. We don't have any means to simultaneously take what we're shaping and what we're looking at formally and gaining any feedback as we might on an automobile dashboard as to how fast we're going, how quickly the engine is changing its rotation, how much fuel we have left in the gas tank. We don't have any means to simultaneously look at this in terms of our design methodology. We have very much an asynchronous sequential design methodology, which again says, let's come up with the shape, let's come up with the form, and then let's apply all of these engineering properties to see if the building can withstand the conditions, rather than saying maybe these conditions can inform our design morphology. So we have our idealism versus the reality, and the reality is this. We haven't perhaps studied the industrialization of the big box stores and how they're changing the landscape and how they're really impacting our environment and how they're impacting our shopping methods. The Apple Store at the bottom is the most profitable retail venture in the world, and Steve Jobs was very, very reluctant to create it. But he did, and they moved forward with it, and does it really talk about our design methodology? No, it really talks about the idea of selling one's products within a given environment and tailoring that environment toward those specific products. Now, what things will change our way of thinking? What's happening? So we have cloud technology that we're talking about. I have an iPad. In today's New York Times, David Pogue writes about this new software company called OnLive, which is essentially streaming a Windows desktop to your iPad. So the notion of having a computer, a singular computer at your desk, probably in 10 years will be tossed by the wayside, and we'll have ubiquitous devices, mobile devices everywhere, more computing power than we could possibly imagine through the cloud, if we use this properly, to design and to start to look at the integration of design morphology and design analysis in a simultaneous rather than a sequential manner. I show this as an example of the chasm between those in practice and those in academia. This was developed a few years ago. It's antiquated technology, but it's technology that's mimicking what we want to do in terms of tactile feedback with regards to the pencil. There was a symposium at Yale that I believe just ended yesterday or today that we might talk about, but the whole loss of the tactile relationship between hand and eye coordination. We're lamenting this loss, we're questioning it, and yet we haven't really talked about how the computer or the digital technology can augment the way we think and the way we like to practice. In something similar to this, but I will also argue that there are several areas that we as a profession have not had serious discussions about. I'm not necessarily interested in a symposium on the loss of using the pencil as much as I am interested in talking about how we're going to publish our work. I believe we have a serious problem in terms of multimedia digital publication that the newspaper industries, that the music industries have already faced or currently are facing, and we haven't even begun to have these discussions yet. We haven't had discussions about how the computer starts to augment our ideas of programming spaces. I show this as an example of one tool. When I was in school, and maybe still you're doing this, we're given a sheet of paper. It lists the project, and it lists the spatial requirements of the project, and we went and cut wood pieces to emulate these spatial square footages, and we tried maybe doing blocking and stacking with pieces of paper or with these wood blocks. But why aren't we looking at this in terms of digital augmentation? We have very few tools that really start to do this. We talk of immersive environments, but here again, the immersive environments are quite expensive. Most practices cannot afford them, even an SOM or larger or similarly large firms. So where do we begin to start to look at what we're designing and simulating what we're designing through the technology? This is one video, if we could play this now. So the idea of the tactile large screen where we can start to experiment not just with images but with text, with specifications, with a whole range of ideas. As I mentioned, OnLive has this Microsoft emulation. Microsoft has also incorporated their touch screen into this technology. So I now have a touch surface that can do this on my iPad. And this was produced by Jeff Hahn at NYU a number of years ago. It was shown at a TED conference to great acclaim. But if you go into any office these days, you're very unlikely to see any of this happening within the largest practices. And so the question is it necessary? Why don't we have it? What are we really doing with the technology? And I would argue to a great extent we're doing BIM 1.0, which is basically saying in its equivalent terms to the automobile industry, it would be like Henry Ford painting a horse on the Model T and saying, well, this is what everyone wants because they're really familiar with the horse. So let's not sell them the car. Let's give them what they're familiar with. BIM 1.0 is saying, let's create this BIM model, which you really can't use here at the GSD in terms of your conceptual work, but we can use it for production work, and rather than laboriously producing all of these separate floor plans and bid sets, we'll use this model, we'll slice it 1,000 times, everything is coordinated, we're just producing better paper documents. So if we can go back to the slides. So the idea of do we publish or do we perish in terms of our influence? We're marginalized as a profession. I'm looking out for you. I care about you. And actually, I think I want to make Thomas my new best friend because I see that what he's doing in terms of elder care is going to be more and more critical. And I want to be there so I get some of what he's developing. But I think that's an untold story that we also need to discuss. Here is the typical relationship that we have, and it's all centered around paper. And it's equivalent to the last scene in Reservoir Dogs where everyone shoots each other at the same time. And there's all of this miscommunication that we have. And here is an example of what we do in the field and someone's idea of how we might be able to do it better in terms of dynamic sections which are linked to specs, the miscommunication of paper. the billions of dollars that we waste going from our bid sets to actual construction. And the fact is that we can create as embellished or as intricate a BIM model as we want. We don't take it into an as-built form. We're relying on someone else, namely the CM, to do that. Or we're demanding this as an additional service, as we rightly should, but we're very reluctant to create the as-built model from what we actually build. We have the stacked paper effect. Here is an example of BIM 1.0. And we're not even looking at the simplest of technologies that we take for granted today. I can track where my shoes are that I've ordered from Amazon.com, but I have no idea where my building components are relative to the project. So we have potential systems that could start to incorporate nomenclature and technology, but we're not really utilizing them. We certainly are labeling all of our building products with some of this technology, but we're not incorporating it into a multimedia effect. And we can certainly look at some of this on iPads, but we're not really thinking in terms of true multimedia and what that might mean for us in terms of our communications, both with our consultants and with our clients. And if we can look at this, this is basically saying, let's rethink our paper documents in a purely electronic form. Might this be what we present and give to our clients? Might we give them this digital model that's incorporating all this information and saying, you're going to have this as your owner's manual. You're going to use this for the lifetime of your building, whether it's your house, your apartment, or your commercial building. Social networking. I'd like to see the day when these light bulbs are tweeting me through my building information model on my iPad or my iPhone and saying, hey, I'm getting burned out, I need to be changed. Just like the elderly want to communicate with those, but not really bother them too much, to say, I can do this on my own, but I need some assistance. Our components should start to talk to us and tell us what's going on. Now, we learn certain things through our own experiences and how disconnected we are and how we refuse to talk to other parties that are involved in our work. So I recently moved to Philadelphia with my family. And I'll tell you something, as you get older, it's good to make changes that you wouldn't normally make at a particular age. So hopefully when you get in your 50s, quit your job, move to another city, and experience this, because you have a certain level of comfort with things that you take for granted. And it's good to challenge yourself on these things. But you learn certain things. And I learned that going through all of these realtor websites in terms of selling my house and buying a new house, that I could look through all of these properties, and my wife and I became detectives in going through all of these photographs. And certainly there are the iPics and little 3D navigations where you can go through the photographs. But I began to think, well, what if my broker, what if my realtor could have said to me, you know what, I'm going to offer you this building information model in your search for your house. You and your wife will no longer have to figure out where these photographs correspond to in terms of a given floor or a view. And you're going to get this building information model. And if you decide to purchase the house, by the way, I can recommend a building inspector. You know, there's a little bit of collusion perhaps going on here. Will the building inspector be involved to getting this house past inspection faster than an independent inspector? But maybe if the realtor is giving me 3 or 4 or 5 architects who are certified in using building information modeling, who, if I want to renovate my kitchen, in some ways are different than a referral to a contractor. And these young architects who may not be employed now have a pathway toward getting their first job and saying to me as the client, look, I'm not just going to model your kitchen and give you a 3D view. I'm going to do the energy analysis on the major appliances that you've chosen, and I'm going to talk to you about the life cycle analysis of these units and whether it's better to spend a little more money now rather than later and get a better energy performance over the design than face something that's cheaper, that's going to cost you more money over the longer run. All of this is dealing with the practicality of practice. It's not certainly the sexy part of practice that we'd all like to believe we should be involved in, but this is giving us a certain level of credibility. And you can go to Home Depot and you can go to IKEA, and they're providing these services. IKEA is giving you the ability to create your own 3D model. Why aren't we doing this? Why are we casting this aside? If it's your first job, this is the way you get started. All the buildings that are fit to print. Well, here's the first BIM model, in my opinion. And Brunelleschi talks not only about how he's going to build the Duomo, he shows the section of the model, and he brings in the hoisting mechanisms to the client to say, this is how I'm going to put these pieces of the building in place. He's talking directly about means and methods. So we can talk all we want about the CNC machines, and now we can even buy them for $500 or less and put them in our home. But even if you're designing a coat hanger and you give all your friends the coat hanger and they put this up and a week later all the coat hangers start breaking, your friends will ask you, well, why didn't you do the finite element analysis of this coat rack or this coat hook? Didn't you know that the form that you created should have structural integrity? So I definitely describe, in terms of what Rivka, I believe, is suggesting, that engineering is, in many ways, the new architecture. And we're going to be faced with this. So create all of the beautiful patterns that you want, by all means. Emulate this to life scale. And I think this is the second area of contention. What will happen when we decide to produce all of this and fabricate all of this at full scale? What recourse do we have to saying legally this is what we want to do and we stand by it? Or who will stand by us? And in shipbuilding, this is a given. Shouldn't it be that way for us? So that rather than creating geometry that has no behavioral characteristics, is just like the Frankenstein model, we want our buildings to think. We want our buildings to be as aesthetically interesting as we want to make them, that are not the 1950s tail fins, and that communicate with us. And if we don't, we're liable to create very badly designed buildings that, you know, the construction managers will applaud. We got this through BIM. We had 0 change orders, but it's really a crummy designed building and looks it. We will have a world of connected appliances. This is a gentleman standing in front of a Samsung washing machine that he can turn on and off from his iPhone. Here is a very interesting example of a Samsung smart window. It looks like it's advertised as a transparent window. It's actually an LCD screen, which can change its pixelation. And ironically, they're showing the pixelation to mimic Venetian blinds. But you can see through this LCD screen. It can give you your weather report, and it can also change the admission of light to your heart's desire and communicate when it needs to communicate. This is a digital circuit breaker panel in the basement of my home. I thought I might as well put my money where my mouth is and start to show you, well, here's the computer screen that controls 8 of these circuits, and I can turn them on and off at will from anywhere I am. And why might this not give me the readout of electrical usage, and why might not it be tied to a building information model, so that I'm seeing virtually what I would see in this model if I were a medical researcher or a surgeon. I might see the same thing in my building. And we don't think about security, but security is another area that is a whole industry that could tie into what we do. And have we examined first responder status through these building information models? And are they giving us the ability to practice fire drills and safety drills and real-time actions through these models? And again, the elder care, as Thomas so eloquently has shown us. And then basically, what do we provide as architects between the tacit knowledge, which is our experience designing buildings, or our experience going through life and trying to incorporate that into our aesthetics, versus explicit knowledge, which is that which is codified. We have very few central sources of codified knowledge. I'm not suggesting that computer provide these as optimized structures or optimized answers, but that we look at both sides of this equation and all of the areas that we really need to have integrated into our design methodology. And BIM is a very small component of that. It's not the preeminent component. It's what's here and what we can augment through the computer. Thank you.
Thank you, Paul, for this provocative but astute sort of X-ray vision and view of the profession. We're running seriously behind time, so I'm going to not delay the introduction of the last and fourth speaker, who is no stranger at the GSD. Many of you know Ingeborg Rocker, associate professor in the Department of Architecture, trained in architecture in Aachen, Germany, as well as at Columbia and Princeton, with a collection of diplomas and master's degrees. It's astonishing. She received a PhD from Princeton. Inge has lectured widely on topics such as the fading flamboyant architectural aesthetics, to parametric design, and education in the digital age, all of which are topics, I think, that are quite relevant to what we're trying to figure out here tonight. As a practitioner, she worked with Peter Eisenman and is now principal of Rocker Lange Architects, with projects and exhibitions mostly in Asia and in Europe. Among these is her villa for the Orders 100 projects, curated by A. Weiwei in Mongolia, China. At the GSD, she has been instrumental in course studio and thesis, and in her courses, tirelessly questioning, probing, and thus ultimately moving a discourse on digital culture in architecture to the next level. Please welcome Ingeborg Rocker.
Thank you. Thanks, Martin. This was a very nice introduction. I hope I can hold up to this. I am in danger maybe to present some car fins, I have to admit. So this is a little bit a cross mix of what we've done here at the GSD with student work, and also what I've been doing with my partner Christian Lang. Mainly these are exhibition designs. Currently we just opened one for the Hong Kong Biennale. That's one of our explorations. So we use these as kind of conceptual vehicles. So Martin wrote nicely when he was introducing us, and I quote this for a moment, digital design media and digital fabrication technologies emerged as foci of design process. The development of digital technologies is enabling new processes of design practice and allows for unprecedented design speculations. End of quote. And yet, is the growing interrelationship between technology and design acting as an empowerment, as an empowering agent for architects? Should we simply cheerlead the ever newer and faster technological opportunities, indulging ourselves in design operations with no precedence to arrive at ever more and never seen design results? Or should we perhaps remain rather critical, reflecting the latest opportunities that technology may give us at hand? And what would such criticality be like? My work is then a search exploring and explicating the implication computation and digital media have on architecture, on its theory, praxis, and education. Nietzsche has argued, sitting half blind in front of his typewriter, that his new writing tool was, quote, working on his thoughts. Today, sitting in front of a computer, one may have similar suspicions. how is this tool working on one's thought and thus on one's architecture? I'm going to talk now about versioning. That's a concept I've developed 2003. Greg Pasquarelli was asking me to write a theory to his AD magazine, and it was quite challenging. He just threw the word versioning at me, so I frankly Googled it first, and what came about was something related to software engineering, and that was it. And that was really it. So I had to come up with some kind of conception about how we could relate this to architecture and the production in architecture. I'm going to quickly talk about this a little bit because I realized putting this together, pretty much everything I'm doing has to do with versioning these days. And I think that's also, we may end up with car fins, but the real interest is to look into questions of versioning and what does it mean to our understanding as being an architect, as the authorial subject, as much as also what it means to the object of architecture. So much recent development in architecture has been significantly informed by computation, and in particular differential calculus. By the end of the 1990s, computation itself and the mathematics of differential calculus gained greater relevance to design. This development was particularly triggered by a younger generation of architects, now not that young anymore, reading Deleuze's interpretation of Leibniz, establishing a new logic of the integration of differences within a continuous yet heterogeneous system. I have here specifically Greg Lynn in mind, but also the Columbia generation of the 1990s. It was in 1686 when Leibniz propagated his idea of differentiation, a method that could calculate and thus comprehend the rates of change of curves and figures. Besides its initial practical applications in ship and bridge design, Leibniz's differential calculus had also philosophical implications, as it allowed the comprehension of nature as a continuous variation. As a continuous development of form, in Deleuze's reading of Leibniz, differences were hereby no longer thought of in terms of separate entities, but rather in terms of a continuous differentiation according to contingencies, a process Deleuze termed folding. And you probably all know this image. This is by Greg Lynn, the interpretation of this type of folding into a formal image, which I think has been highly influential in our profession. And I think a lot of the car fins, the architectural car fins Paul was showing, I think probably have their origin right there. Perhaps most notable, architecture form designed with software based on differential calculus changed from fragmented polygonal rectilinearity towards smooth, continuous splinal curve linearity, subverting both the modernist box and also its deconstructionist remains. Much attention is given to Leibniz's differential calculus and its ability to fuse the hierarchy of parts and whole to produce a deeply modulated whole, as well as infinitesimal variations among parts. The implication of Leibniz's mathematics for architecture is explained by Peter Eisenman already in 1993, when he wrote, I quote, Leibniz turned his back on Cartesian rationalism, on the notion of effective space, and argued that in the labyrinth of the continuous, the smallest element is not the point, but the fold. In mathematical studies of variation, the notion of object is changed. This new object is for Deleuze no longer concerned with the framing of space, but rather a temporal modulation that implies a continual variation of matter. The continual variation is characterized through the agency of the fold. No longer is an object characterized by an essential form. End of quote, Peter Eisenman in 1993. Eisenman depicts here what I first termed in 2003 versioning, thinking then of design no longer as a single entity characterized by an essential form, but rather as a series. The concept of versioning and the opportunity to rethink the architectural object. Now, replacing the notion of a determinal substantial object entity through object versions, through relational constructs, versioning offers an alternative perspective on objecthood. While unversioned objects may be considered objects that merely occur in a single state, namely the current, the present state, which becomes overwritten as it is modified, each version presents a state of an evolving item put under version control. Versions may therefore either be performed as revisions, superseding their predecessors, or as variants, coexisting with their predecessors and antecessors. Each revision or variant, a snapshot of an instant in the evolution of the object, is constrained within the versioned object. Each revision or variant becomes solely identifiable in and through its complex relations to all other revisions. Links and relationships record the predecessors and successors as they permutate and hence constitute the object differently each time. This process is documented in the revision history, an archive of past revisions that record the work's evolution over time. Identity evolves and dissolves like a diffuse network that continuously transforms and therefore becomes rather than exists through the profound play of differences and repetition. Within this reckless process of becoming differentiated, which we will examine more closely in the following, the object's versions occur merely as temporal stabilizations, hence dismissing both the former belief in an ontological permanence and static architecture. Instead, versioning opens an alternative perspective onto repetition and difference, rendering representation in the sense of the repetition of the same problematic. So, and with this said, also obviously these kind of concepts as we have them through industrialization and mass production of repetition of the same have been thrown up for question. I think I'm going to... So differential calculus presents then a challenge, if not a catastrophe, for architects' planometric means of representation as well as for the means of production, which simply cannot cope with the spatial and temporal complexities which are so characteristic of the fold. And I don't think of the fold right now kind of metaphorically, right? With the new means of presentation, new realms of architecture thought and production become possible as the designer is liberated from the constraints of traditional models of presentation. Now, younger architects, and that is including myself or Rocker Lang, have obsessed with the possibilities of differentiation, most often reducing the concept to mere surface effects. And I show you now a few of these surface effects. So this is the work from ours. Those are our acts where we had to heighten the idea that we are capable of differentiating, infinitely differentiating, as you could see. Whole families, obviously also the means of representing it had to be now in a matrix. It will be the matrix in order to showcase the capacity and the flexing of the differences. So I would argue that we here are doing nothing but heightening, fetishizing the idea of differentiation and kind of reducing it hereby to a mere surface effect. At best symbolizing rather than taking advantage of the computer's power, the tireless looping, its ability to perform millions of operations in a single second and to constantly shift and recalculate functions. It is not just the curve which began to characterize computed form, but the parametrized curve, the folding and shifting of the two-dimensional curve across a third dimension. Not even the curve alone, but also its derivates and inflection points, the core of calculus-based mathematical analysis, is that which began to inform digital form-making at its deeper level. Architecture is viewed neither as fragmented nor contradictory, but rather as an integrative, intensive whole. With computer-controlled manufacturing techniques, infinitesimal variations, and once-of-a-kind customized variety, as Lynn was talking about in 2004, became possible. But was the possible also plausible? Many of the results were often grotesquely dysfunctional, uninhabitable, continuously differentiating surfaces, which were at best rigorously generated. In architecture, the continuous differentiation of an imagined continuity resulted in little more than an exhausting and now perhaps exhausted exuberance of form, which seemed to have finally found its end, and I am afraid much of what I'm going to show now has not ended it. But we will see. So it's a search, as I said already before. So now we're going to turn into, I'm going to discuss a few projects. First, those which have been done here with students in the seminar called On the Brink. It's a brick on the brink. this is our object of interest. And I believe that the brick is on the brink simply because the brick is standing for, on one hand, first handmade, man-made object, which then became aggregated, and then second became increasingly more mechanized in the vein of industrializing the production of bricks. And finally, I think we arrived at a third stage where we could say now in the vein of computation, the brick and its qualities have once again dramatically shifted. So I'm going to shorten this a little bit in the interest of time, right, Martin? What do you think? So here, obviously, we see first productions of brick, how they were traditionally made, essentially just earth ramped into a form. The result is a rather irregular type of wall. Then industrialization arrives. We see the standardization, mechanization. The brick becomes standardized, normatized, engineered. Also engineered and normatized the ideas of how walls had to be measured, dimensions are fixed, bond systems are defined, techniques of building the wall are defined. Still rather crude, and yet still we're working here with an industrialized material. Now a shift from mechanization to computation. We have a mass customization of the placement. This is top an image from here, but it's also analog to what Gaimard Zirkola has done at the ETH Zurich. Mass customization, meaning the relationship of the bricks to one another can be customized, whereas the brick itself remains a module. We could also think of the brick itself being versioned, changing, as here in this case the work by Greg Lynn in the middle suggests. And then finally, and this all is based obviously on the digitization or the use of computation, as already was suggested earlier today. So now our first exploration, mass customization of the brick. So this is a work we have done in 2009 here at the GSD. The research focused on two primary explorations. The first was to develop a method in which the geometry of the brick itself allowed for curvature in a surface rather than using mortar or air gaps to achieve curvature. The second was to find a brick that had its own identity, resisting subjugation to a surface, even as it changed to form that surface. Now here we see, first of all, we just take a principal dome. We use techniques of projection to define and discretize that surface. This is a re-understanding of the brick, not just as a massive module, but along its sides, understanding each side essentially as a malleable surface. Here we can see questions of curvature. So what will be curved is a brick, if a brick constitutes a curved surface. Is it the brick overall curving, or are certain parts of the brick curving? Then here we have this kind of discussion. Are the sides curving that touch the brick? What are the techniques of fabrication we have? We have, in this case, used the water jet. We have available here, and we actually used existing bricks, which we cut then in order to achieve this curved surface. And then another question is, how would then yet remain the brick in a single unit, still legible? And how far would it not be subsumed totally smooth into the surface? Let me see, I think we should have. Okay. So we were building a model within which you can see the bricks being aggregated hypothetically right now here without any gap in between them. So each of the bricks obviously has to immediately relate to the neighbors, and you see in how far different relationships are explored. Then we looked also at classical samples, such as here the dome we have seen already today. We were particularly interested in the herringbone as a technique of assembling or aggregating the brick because it seems suitable in order to avoid scaffolding. And here we have an analysis. Again, you can watch the brick on the right side. This is the red one, which is highlighted within the field. And what we're doing here is we are indicating the degree of curvature as we change the curvature of the overall surface. The idea hereby was that the top surfaces of the brick would not change, whereas the sides would be then curved, and obviously that was limited to the capacity of the water cutting because the beam of the water could only achieve certain degrees of curvature. So in the end, then also we were looking at software which could allow us to arrive at a proper structural system for this exploration. We were looking at some freely available software by Axel Kilian in this case, which is a catenary kind of simulating a catenary system. The surplus of this is that, as we have seen already from the actual hanging model, this is the inversion of it. But since the hanging model is all in tension, the moment you turn it upside down, everything is in compression, which is extremely handy, particularly if you want to build out of brick, ideally with no mortar or anything else gluing it together. So that was obviously a hypothetical, nevertheless, so we were through a couple of formal explorations, came back having defined a form, and then the question was, in how far would we then properly populate it with the bricks? We used for this purpose Grasshopper, which is not ideal, but is highly intuitive and very quick in order to get the job done, which was necessary for us here. So these are a few images of how brick populations were thought. Here we see how the actual bricks were cut. As I mentioned, they were existing. We kind of recycled existing bricks for this here. We were also talking about green bricks, which are not burned yet, but that wasn't really working for us. So we used here existing bricks, and what you can see is the bricks are curved on the side flanges as they meet. The brick itself is always peeking out a little bit. That is in order to maintain it's not a mistake or an error, but it's purposefully because we wanted to have it reading still as a singular component within the aggregation. And here we see a visualization of how we imagine this dome to work. You see each of the brick peeks out and yet is also subsumed within the curved surface. The next project is a project which we were interested in, again, looking at parts to whole relationship. This time we wanted to customize the brick as much as the opening of it. Those are cardboard bricks. We wanted to purposefully shift material because the heaviness of the actual bricks were really not helpful for us to be fabricated here. And plus, we also liked the challenge of recycling it easily, plus working from a two-dimensional material into a three-dimensional quality. We were looking at the Lamarck surface, which was nice because it is a mathematical equation which generates the form, but what is also nice about it, it allows you to create an inside and outside condition within through a single surface. Here are some examples. You can see as you change the equation, the characteristics of the surface is changing. In the end, we were choosing this one here as a configuration where the surface was lifting up so you can slip into this type of pavilion we have worked on here. Then further ideas of discretization came along with questions also of structuring it. You can see here again the units are populating the surface. Obviously also material constraints were playing a role in the sizing of it. In the end, these are the units on the right side. You can see the geometry has been developed in such a way that it is stiffening the two-dimensional materiality to a three-dimensional brick unit made out of cardboard, but also to allow for an aperture to occur. The aperture and the brick geometry are flexing depending on the degree of the curvature which then becomes constituted through the brick. So it was a back and forth between an existing curve given through the mathematical equation as much as it has been also kind of a feedback loop between what the material properties were, but also what the physicality, the minimal scaling of the brick
allowed us to. Then much work was, or much effort was put in the
actual engineering of the brick, because we obviously wanted, for aesthetic reasons, a minimization of the seams, but also for technical reasons, because all of those had to be glued. And then in the end, it was also about saving material and money, as these bricks possibly could be in a most efficient way being laid out on a chipboard, which still would be possibly cut here with the facilities given at the GSD. So then much effort went into, obviously they all had to be labeled, numbered, etc., because all of them were different. In the end, we were really wondering in how far this continuous differentiation really was helping us, or in general makes any sense, by the way. But for the sake of working it through, here you see how we laid them together. There would be then a chipboard connecting piece going through the vertical seams you're seeing. That's also why you still have that little hole on the right side of the brick that was a kind of piece which we were filling in after we tied them together to the vertical piece. Here the construction is under its way. And maybe a quick thing to give you a feeling for the overall scope of the work. What about our sound?
If I don't know it, there are only pieces of me. What's the use in dying, if I cannot see?
Okay, and now we're coming to something Will and I really quickly were working on. The animation was also by Will Choi. Thank you, Will. So this one is now taking it a step further. How could we bring this project from this kind of hyper-theoretical or, let's say, exploratory realm, where it was really about the challenge of how one customizes the brick units, creates brick units made out of chipboard, into something which would be in a feedback with real data, or at least some assumptions thereof. So the question was then, how would we look at the apertures and the geometry again, but putting it into direct feedback loop with ideas of shading sun for different time periods throughout the year, or also for different locations. So what you see essentially is a flexing of the apertures linked to the sun angle at different locations. And there's a close-up coming, which I think this makes it even clearer. On the right side, you can see how the sun changes in respect to the So the question obviously would be, would we mechanize those openings? Most likely not, knowing the centre, how was it called, the Mont d'Arape, right, in France, Paris. I would say we're not going to mechanize them, but what one could do is one could look at different sun shades, for example, and again, this is only working through a model rather than an actual project, but looking at this, one could define the apertures in order to allow sun to come in throughout the winter times, and then prohibit it because of the location of the aperture. And as I said, also the brick is always considered as having two fronts, a back and the front, and you could, by relocating the apertures in space, you could also allow sun to come in at certain moments and then deny it at others in close correlation with the angle of the sun. So now I'm coming to our own work, which probably doesn't make it easier, but let's see. These are coming now, the car fins, I'm thinking. So this is work we have done in 2009. Again, this was for a biennale. It was the Hong Kong Shenzhen Biennale. So we like to use these moments to get work out. And this is called the Urban Adapter. The idea was here to develop a furniture. So there's something highly annoying. I don't know whether you ever are aware of it, but there's even a huge business out there because they are used for advertisement furniture these days. J.C. Decaux is one of the really wealthy men in France because he is populating our cityscapes with advertising surfaces which are linked to street furniture. So, but you probably all, if you think about where you were sitting yourself most recently, there's a park bench, I'm sure, and the park bench has some style of some sort, whatever one mayor at a moment in time thought would be best suitable for your city. Anyhow, so this is not suggesting really a new style, but this is suggesting an alternative understanding of how one could think about these type of furnitures. And we thought of them as a family. This comes back to the idea of versioning and the question of how can one think of it not as a unique design object, but rather as a principle of operation, which then can be actualized as it goes onto certain sites, or also as it has different type of functional requirements. So we thought about it as a vertical element for advertisement, could be also educational information. For example, a box element, which could be trash, could be also a bar, could be flower bucket, mailbox, regular sofa, bench, could be converted into bed, probably a stool. So essentially it was made to be able to follow all of those different criteria. On the right side, you see behind it, there is a bigger vertical element hidden. The front leans more towards becoming a bench or bed. So here you can see each of the sections you could also consider being a version of its neighbor, because the way it's working through is coherently. You see the rods which are connecting it. The material is recycled plywood, which is water tight. This is the bench. Has been used in very different ways we have imagined, but people had a lot of fun with it. So now I'm going to talk about something I think I'm going to read again, which has to do with Hong Kong. So our work is generally centered in Hong Kong. It gives us the urban intensity we like to work with. And this one has been also a piece of Biennale. This time it was the Venice Biennale in 2010, where we exhibited the piece called Serial Architecture Systems of Multiplicities. Here we rethought the quotidian architecture in Hong Kong, and Hong Kong is a city which has an average density of over 6,300 people per square kilometer. It's one of the most compact cities in the world, and it's a quite diverse and complex place with acute physical constraints that have created an extreme form of urbanism, and which also inspired our response to it. So here we see the urbanism. It's all limited on one strip. This is more the inner of it. Then here we see a very typical tower floor plan, which developers would multiply. And here we see the result of it. It's an incredible monotony, which then they try to soften a little bit through different colors across these towers. Now, our suggestion was then, why not taking on this typology, not necessarily challenging it altogether, because if you look at it carefully, it's hyper efficient. So if we talk about efficiencies, structurally sound, apartment sizes, also light, you have it all. It is totally pitched out. So I would say the BIM model couldn't do much to it, if I may say. But for us, it was somehow looking at it from an architecture point of view, but also looking at the monotony we received there, and also the suicidal rate in Hong Kong. We thought we need to do something. So because of this, we came up with, and this is a simplistic version, and I'm happy to receive lots of criticism for it. We thought, okay, what about if the core stayed straight, because elevators like to be straight? What about if there's a zone of intermediacy? You see that as light gray on the right. We keep the apartments more or less as they are, even the gaps between them, but we introduce a kind of neighborhoody condition with light to the core. So, and that's what we started with, and we developed a parametric model. It's again Grasshopper, because that's what we can work easily with. And we set up a set of criteria, certain height, obviously, but then also a flexing within the model, which allowed us to create differentiation. Now, I'm running you quickly through matrices. And again, this is a method. It's not to be taken as the actual piece of architecture, or that this would be our new urbanism. This is really a model of operation, a model of thinking. So here's matrix 1. You can see they come from very straight to totally erratic. Left is rather calm. Lower right is always probably most erratic. So we worked with different, parameters, looking at different sizes of the apartments, looking at different exposures to light, but also looking at obviously still some structural concerns we had. Here we have, by the way, the process was automated. So I wanted first to bring in a 450-page book. I had a fantastic student, Wes Thomas is his name. He automated the overall process. So we have, this book was literally automated in terms of its representation of the matrices, but also particularly here, these tower. Each floor plate was laid out like this. And then here you can get a feeling for how the units are rotated towards one another, creating some outer space if one wished to from one level to the other. You can see also how ridiculous the project turned, where on the top floor plan you can see one unit simply was reduced to its load-bearing wall. As parametrics works, you can set up the parameters unto where effects occur, right? First, left side, nothing. I think then 1/3, 2/3 full impact. And then those are the elevations. If you look at the array of what we have created, the different matrices, we would have now these elevations. Obviously, they're commentary on the monotony I've shown you before. I'm not sure they escape that monotony at all. I think they just create another type, a little more erratic. So obviously, the way I'm treating this, you may already hear from my commentary, is this is a search for something what this idea of versioning could bring to us, but it's also a kind of self-critical search. It's ironic. It's also critical of parametism and the fetishization of continuous differentiation to a certain extent. I don't think it has produced yet something which I would like to put forward as a serious project of architecture, which I would be happy to have built tomorrow. But that is, I hope, not too far in the future. So now, on this nerve, I hope you can hang in one more. Okay, wait, quick. So I do one more quick thing, and then I conclude. And I will go very fast. Okay, we're back in Hong Kong. Now we're looking at the absence of proper public space. There is a lot of space, but it's not really public any longer. It becomes interiorized. It's kind of mall systems. And yet it's highly interesting because it happens on different levels. Hong Kong is a city which develops vertically very interestingly, partially because of the terrain itself, but also because of the high density. So those are diagrams which stem from a book which just analyzed Hong Kong's dense urbanism, and I'm just using them as a springboard. We have differently done diagrams as well ourselves, but I didn't have them ready at hand today. So this is a shopping mall which is ad hoc created within a department building. Within an office building. And so here the public space in red takes over that which was before private and a private interior, if you want. And it becomes kind of shunty, small scale, almost like a market-like situation. And then here we have suddenly an entry level, I think it was 17 floors above where the actual lobby space is. So those are the these conditions we were interested in, we would like to further develop, but to radicalize the idea of having public space on vertical levels. So for that, again, we set up to develop a matrix, and we were starting out this time with some type of typology. On the left side, you see urban typologies, existing typologies, which we then started to develop to different degrees of how we wanted to integrate urban space. And you can see on the left, there's nothing. It's like the typical extrusion. And then we kind of worked in successively, more so on the right than to the maximum extent, public space, which we could imagine to happen on almost every floor. Then we linked this also to a development of the core and the escape stairs. Those thinner kind of erratic nervous systems are the escape stairs. And the other ones are the disjunct cores. Those are the newly developing public spaces. Those are the models currently on display. Okay, and I leave you with this to be read by yourself. I hope you finish, or should I read this? Mark, you give me some signs I don't understand.
While you keep reading, why don't we ask the speakers to begin sitting down? And we're running slightly behind time, so we're going to still, why don't you, yeah, maybe, can we have the lights a little bit more? Thank you. I think quite clearly we brought a broad range of perspectives to this evening. This was quite intentional, and also acknowledging the fact that we will not get a kind of consensus on what the issues and problems and opportunities are as far as design technologies are concerned. In a sense, there are two different approaches or mindsets at play. There's a sort of design opportunity and using technology as a way to broaden design scope. That was clearly true in Inge's presentation. Also very much in Rivka's presentation, where it's more an emphasis on process, the kind of processes that are enabling these sort of new forms of collaboration to happen, which in a way, Paul said, actually, this is still very much behind the curve. And then Thomas' work is taking, again, a slightly different perspective where there's a real-world problem, and there are ways to potentially address that involve technologies in a very intense way. They also involve design and spaces, so it actually becomes to be a very, very broad problem. But I think one could argue that compared to some other fields, the building industry is not the most sophisticated field. And knowing that you've also worked, Thomas, on some other issues in automatic construction, why is this? So is it the failure of the academy? Is it why is the building industry not in a better position? Why have we not advanced more quickly? Why we're still using bricks, the same bricks that we used thousands of years ago?
Okay. Is this on? Yeah. Well, maybe this depends because of the the product we are designing has a very long life cycle, and the learning curve is also very long. So it means the designer or the architect, they live shorter than the product they design. And many happens very often. So the feedback is very slow. On the other side, for example, if you buy the bread or the bagels every morning, you get the one who makes the bagels gets the feedback the next day if it wasn't good. So I think this is one problem, and then of course another problem might be that also we have this how to say this. I think even so, lots of people now talk about the tools, and also today, I think we somehow lost actually the link to the tools, like the vernacular stuff you showed, Rivka, was very interesting, and I have the feeling we lost this, and we could regain it again by this technologies we just talked about. And also you mentioned this with the, I think it's very important that, like we're doing with our students, one exercise where the students have to build by themselves. Do-it-yourself experience, I think, is very important before we approach the machine. And this so we have lost it somehow. But we could actually regain again what the master builders had. The French master builders, for example, the great French cathedrals, and then this could be possible nowadays with this technology available. So what I'm a little bit have a problem with is actually that why would we like to give away the creative part of design? This is a little bit my problem I have with maybe this technology we just talk about today. I can understand all the algorithms, whatever we develop, in order to make it easier to further process the design. But somehow I would think I wouldn't like it as my personal point of view to give the creativity part away to some algorithm which I developed, or so I would rather but this is a very subjective personal opinion, keep the creative part, and then because of this potential of automation we have here, what everybody showed, it would free more space, more time to be creative, because when you look at the practice of architects and engineers, most of the time they're dealing with communication, with management, and so on. So actually there is not much time for creativity. And I would rather use this technology to free more creative time and space for the design, and then automate the repetitive routine work. Because this is also the motivation which is behind my work. I think about, since I built my first building myself, when I was 22 years old, I had all this experience when you hurt yourself, when you try to make a brick wall and all this stuff, and concrete and reinforcement, and you make lots of mistakes, and then you start thinking, oh my God, why can't we do it differently? Like the car industry, when I was in Stuttgart, I went to the Daimler-Benz factories, and I could see how differently they work. So I think this is the thing we have to use, and maybe one strategy could be that we apply more of this in construction, would be that we break the components down, like you showed the bricks. It's very good, and especially Boston is a town of bricks, so you see many different kind of bricks. The old buildings have smaller bricks, and the newer buildings have bigger bricks. So you see the development. So if we break it down to the component level, we can innovate maybe on a faster cycle in the future.
So in a sense, in the beginning you mentioned that we don't seem to have a good way to actually capture that knowledge that is being constantly produced. It is also constantly being lost. So going back to some of the projects that Rivka showed, that you alluded to, Paul, and in a sense that also a little bit in the spirit of the things that Inge talked about, is there a value of this sort of experimental practice, like Kieran Timberlake, right? The kind of young practices in terms of spirit, I think, that try to really experiment and use a practice as a lab, so use actual projects as the research lab. Is there value, or will that knowledge just get lost? Is it just project-based? Do we have a mechanism to feed that project back into the process so that we get to a kind of incremental process improvement and learning?
Well, I think Kieran Timberlake is a very good example. I mean, one of the values that they're bringing is this very methodical approach toward design, which most firms are not doing. So from that, we can take away that this is important in terms of methodology, the rigors of methodology. But to what extent are they taking this methodology and codifying it or publishing it so that others can learn from this? And certainly they're trying to publish this so that others can be inspired by it. But there really is no central repository of what we've learned. when I looked at the presentation from Inga and thinking of Louis Kahn, and I asked the brick what it wanted to be, and so there's no repository that shows all of the things that the brick wanted to be. I thought of many different things watching your presentation. One of the things I noticed is that when you codified the typologies of all of the building massing, that there was very little of the view from looking inside out. And I started to think, and I hope I'm not perverted, but I started to think of the 1940s pinup models that you would see on airplanes or in magazines, because we start to use the technology to objectify. And I think that's part of what I was trying to show with Separated at Birth, that we're objectifying, but we're not experiencing. One goes... It's very rare that one goes into a piece of architecture and says, this is a piece of architecture. One goes into a building by Gaudi and says, I'm experiencing architecture. One goes into these apartments in Hong Kong and says, well, I'm home. My family is here. But there's very little architecture. We don't experience this. We experience it more by taking a refrigerator box as children and making it into our playroom and cutting holes in these boxes and experiencing light penetrating the simplest of forms. But we very rarely get to experience architecture. And this is a concern. I also noted in Thomas's remarks in regards to your question, what is driving this disconnect? And it's money. It's pure economics. The big box buildings speak to economics. It's fast to produce those buildings. We have achieved all of the industrialization that we wanted to, that the modernists sought. But we've lost part of architecture. And even in the remark of the bagel baker or the baker, we're now seeking these. We want the mass production, but we don't want Wonder Bread. We want the bakeries that can be found in any city, but we want something that speaks to customizing toward our needs.
But isn't money driving every single industry? We're not unique in that, right? And yet in other industries, one could argue, not from a design perspective, but at least from a process and production perspective, things have moved along very quickly. For that reason, in fact.
Successful mass production can be found in an iPod or an iPad or an iPhone. And where the technology is successful versus all of the other companies that are trying to do the same thing is that the technology allows the user to experience a sense of individuality and a feedback response. Now, this is very interesting because architecture, when it's successful, it speaks back to us. When it's not successful, we feel like we have no control over it, that it's basically an inhabitation. And so we need to start to understand what user feedback means, both in what essentially what is a 2D landscape of the surface technology in a phone or an iPad, and what is the feedback in an inhabitation and a piece of architecture.
Mentioning the iPad, etc., Steve Jobs, products, there is a big difference between product and architecture. Product can be mass customized and given to the user to make creative things. So the product can be, the product comes with millions and millions of copies. But when we give a house or when we give an architecture to the user, it has to be one-off. So we cannot create architecture as products for the user, there is no parallel between product and architecture. Although we term the two belong to design, to the skill of design. But I just want to ask you how you define architecture.
Mm-hmm.
Well, if we are talking about how do we define architecture today?
Well, I might disagree with you, Rivka, about the ability to take a product.
First, define architecture.
To me, it's experiential. I look at a piece of art and it talks back to me, but a piece of architecture, it sends a chill down my spine, and it makes me think of light and space in ways I haven't thought of before.
Well, that's really very. I'm looking for a definition that is more.
And yet it's intellectual too.
Yes.
We cannot separate the intellectual.
We cannot work with your definition. You see, your definition is subjective, and it's yours. And if we want to understand architecture, we need some generic or general, definition. Otherwise, we don't share anything.
Well, I recall a dean of a very well-known architecture school saying to me, look, architecture is not about building. It's about the difference between this building something and the intellectual disconnect. I mean, we look at Alberti and we say, now there's the beginning of architecture versus building, because there's an intellectual component. We look at Greg Lynn, we look at Leibniz, we say there's an intellectual differentiation.
So you recognize architecture.
I do recognize
you recognize that. That's the way to recognize, but how to define it, we don't know. We know when it's there, but we don't know how to get there always.
Inge, do you have any thoughts on this? Can you help us with architecture? You're teaching it. Sorry.
I thought I'm teaching it.
I don't know.
Yeah, and no, but it's a funky thing, because I agree with you in your criticism towards the questions, or also your criticism about the automation of the design process, right? And I think that's right now. Let's say I put this work forward, and I believe it's a critical commentary on architecture, my work. So it's somehow architecture because it is discursive, as it's tackling certain subject matters and problems, I think, that are architecture in nature. Let's put it that way. Now, the tricky beast is, though, I would withdraw from suggesting any of these things I put forward today as being architecture. Do you see that? So the project as such is architecture, but each single entity is just, for me, an instantiation of a model. And it's not. I would not confuse that with a piece of architecture. Do you see it? So there's a little. Maybe I'm just withdrawing here in an easy manner, but that's what where I have a difference right now. Now this is not a happy situation. Let's put it this way. I'm not happy about this. I rather would like to produce architecture as an outcome. So therefore, I agree and accept the criticism. I don't think that automation of the kind I have presented tonight is allowing us to arrive at good architecture. Let's put it that way. Nevertheless, I believe this project I'm currently conducting in front of you here has to do with architecture. Okay, so maybe that's my way out of this question mark.
It's a pretty good way out, yeah. I do want to open up. So if there starts questions, please by all means. The time when it's late, so why don't we maybe take your question over there?
Hi, my name is Jason Lee. I'm a practicing architect in the Netherlands, and I'm here just visiting for a while. I just had a question to everybody on the panel about, sorry, there was two questions, and I'm losing them right now. Oh, yeah, sorry. One was about, in Rivka's presentation, which is something that we're directly confronted with daily in the profession, on a lot of your slides you had design to production, which is a very well-known European office that's doing a lot of the technical working out for fancy architects like Shagrubban and Zaha Hadid. And then also Biro Happold and Arup and all of these, Gary technologies now. I was just wondering, with the disconnect between the kind of technical side of working out a building and the aesthetic control part, which seems to be more and more the role of the architect, I was wondering if you guys could speak to that, because there was some mention of the word master builder and the kind of relationship between that? And that was the first question. And the other one was, seeing as both Paul and Inga know quite well, I guess, shop architects in New York, is that sort of the only viable model that we're seeing, or is there another model of practice where we can marry the technical and the artistic, I don't even know what to call it anymore, architectural elements, components?
I believe that the architect today should know much more than he was given, 10 years ago, etc. And I think, well, you said engineering is perhaps the new architecture, and architecture perhaps be the new engineering. So it's not, it's a dual way. We have to merge together again, because understanding architecture without engineering principles, it's halfway through. So these experimental offices which work together really produce interesting things, because they work together in a different way than just BIM. BIM still work by silos. If we can break these silos and get another BIM which could really talk to everyone at any particular time, then perhaps we could get something else. But BIM is very much imitating the old tradition.
Well, I agree with you completely. And I think BIM is, as I was trying to suggest, BIM is a vehicle. It looks at geometry, but the broader implication is for performative analysis. Where we're limited, I kept hearing Inga say, we used Grasshopper for this because we could. We should be teaching the students of architecture how to work in computational development, to create new tools. This is as important as creating these models. We need to have these languages that we develop. If I told you that every surgeon was using medical equipment made only by Johnson & Johnson, you'd say, well, that's crazy. I mean, there's no competition. It's only Johnson & Johnson. So we're subjecting ourselves to this intellectual limitation of having certain software developers who really don't know what we're looking for anyway. They're trying to discern that from us in producing our critical means of communication. We need to re-examine this in ways that doesn't make it too complex for us, but allows us to communicate what we would normally want to do.
How do you address the life safety issue? I mean, somebody's got liability is probably the most pressing concern.
That's where
safety
it's a
and liability.
collaborative effort, and that's where we talk about the auteur. We still elevate the auteur, and I'm not saying we shouldn't elevate the auteur, but there needs to be an understanding that there are auteurs, that we collaborate with a variety of groups and individuals that perform a critical function in what we do.
May I say something?
Well, actually, in the interest of time, there was another question, and I think we'll make that the last question since it's actually quite late. Thanks.
Okay. This is a question again for Paul. I was a bit confused in your talk because I thought you were a bit opaque about this. You kept talking about these wonderful technologies that students of architecture have, and they're not in the real life. But I could never really pinpoint exactly what technologies those are. And I think in it really, I mean, I really like some of the things you just said. But it really makes me wonder if whether you're right on spot or missing the point completely. And this is because there is, I mean, any computer right now has more computing power than what NASA had when they sent people to the moon. If they did indeed, I don't know. But, but the thing is that there is this certain sort of idea of working always on the edge of this opaque technology, this very...
Okay.
And understand technology, and we haven't really exhausted the technological possibilities, not even of things that are thousands of years old, like wicker. like wicker weaving. Those things are still giving us surprises. So I think the answer is not really neither in BIM nor in parametrics, the explicit parametrics, but in a sort of a parametric thinking or deepening those thought models. That to me is the actual contribution of the computer, is that it really radicalizes the way you think, not so much the way you do.
That's correct. Let me clarify certain things, that the accessibility to water jet technology, to certain laser cutting or CNC technologies, which you'll find readily in the schools. And the schools now have to provide this in order to compete and differentiate themselves. But you're going to very rarely find this within the practices. You will find a laser cutter at SOM. You will find a 3D printer at SOM and at Kieran Timberlake. But the larger scale, it's interesting because Kieran Timberlake has a very large facility, and they have a shop, a big shop full of table saws and drill presses, very few of which are digital. They are traditional mechanized machines. So the idea of having a digitally accessible fabrication or any sort of robotics is what you might find within academia, but you will very rarely find within practice.
Yeah, but for instance, staying on that subject, I mean, if you're here in MDAS, you'll probably be using the CNC router to do amazing stuff. If you're an architecture student, you're probably using it to do site models. It's really not something that influences so radically the way you talk. And okay, laser cutters are wonderful, but there's a lot of you can still do with a printer and a cutting knife.
I agree.
mean, it's
However,
not the tool that
we're
holds
talking, what we're principally describing is representational modeling, and this is what I alluded to in the presentation. Representational modeling versus modeling to full scale. And this is a whole other discussion which we as a profession have not come to terms with. And again, in terms of multimedia development of our instruments of service versus the static paper delivery of ideas. I suggested very casually to one of the field architects at SOM, what if we plotted on both sides of the sheets? Would that make any difference to you? And he said, oh my God, it would cut my load of carrying this paper in half on the job site, and I could also refer to what's on one side of the sheet to the other. But what we're doing now is we're basically creating this book where every 5 seconds you have to go to the footnotes in the back. So we're not even looking at any of the technology that might radically change how we communicate to others.
We'll wrap it up. I think clearly we have not done some very obvious things like double-sided printing, right? I will also say well, it's true, right? It's shocking. I will also say that the sort of existence of somewhat sophisticated facilities in academia isn't necessarily justified by the hope that you will find them when you go out and practice in the offices, but it's also in the hope that you will learn some of the principles involved in dealing with those new tools, not because your fabricators may be using them. And if you understand what they do, then you may be able to design your buildings in a way that makes that work easier and also the workflow easier between architect, engineer, and fabricator. But we'll wrap it up now. Thank you very much, all of you, for presenting, for coming, some of you from very far. And for everybody, thank you for staying here this long, and have a good night.